Testing. Okay. Hey, Joseph. Hey, welcome on in. Happy Sunday. We're going to be continuing our Burn adventure. This is the Rust library for deep learning. We are going to learn it as kind of the same way that we've done with the PyTorch library. And I'm pretty excited about it. This is what we're going to do. And I'm going to be spending a lot of time typing today. I'm going to spend a lot of time typing. So this is where we left off. Let me see where our code is. Joseph, thank you for your comment earlier. Yeah, this is basically kind of what we're doing. We're going to be comparing Burn library to PyTorch library. Is it actually that much better? I don't know, because we weren't able to saturate the CPU even with Python with the workload that we were giving it. I think we can do that just the same outcome as Rust. So we're going to figure that out. That's what we're going to do. Let me see if this is running. Hey, Quick Fix, good to see you. Welcome on in. Happy Sunday. Good to have you here. Cargo run. Let's see if that bursts out. Looks good. All right. A little bit of warning. No worry about the warnings. Hey, Bonzupi, good to see you. Happy Sunday. Welcome in, you guys. We're all here. Quick Fix, Joseph, Bonzupi, and the Rocks too. Hey, all right. Everyone's here. Good to have you guys here. Thanks for saying hi. All right, let's get into code. So what do we need to do here? At a glance, you can view the model's configuration and print the model's instance. Oh, we can print it out. Okay. There's some sort of recursion limit macro on here. I don't know what we're going to use that for. We're going to put it on there. We're going to find out. That goes on the main file, right? So let's open up the main file. We'll go source main macro. Wait. Macro. There we go. Your computer idles on 850 megabytes of RAM and you feel so snappy. Your new custom. Oh, that's nice. Hey, that sounds, you know where, here, look at what my system's at, HTOP right now. All right, look at this, 69, 69 right now, 69 gigabytes. What is going on? But your touchpad's not working out. Oh, you got to fix that. Oh, what? Rust by? Oh, wait, no, Quick Fix, I know. Hey, it's okay. Rust is actually a lot of fun. It'll be fine, I promise. Got to get that touchpad working. Nice, make it happen. That's that touchpad. I like my touchpads. Here we go. Okay. Just joking. Okay. I know. Oof, 69 gigabytes, right? That's crazy. All right. So cargo build. Just let me double check that everything looks good there after I did that recursion thing. Okay. Sounds good to me. Looks good. Okay. Create model config. So we're gonna import the module that we created earlier. And we're going to have a WGPU as the backend, which is weird that they want us to separate these out. It's very weird that they want us to separate those out. So let's do that here. I'm going to type these in by hand. I want to type these things in by hand. So that way it helps me memorize it. But use module. What was it? What do we call this? Create. Oh, sorry, right. Create, which is the scope. Create model. And then model config, right? Model config. We've got model. Wait. Module and
I cannot believe
module.
Fable.
Let's see, 1 second. Get the next song going here. All right. You have Arch Linux machine that idles on 250 megabyte, a quarter gigabyte. Nice. In 2019, I don't know why it can't go that low anymore. It should be able to. It should go lower than that, even lower, I think. 250 is a lot of megabytes. You only have 8 in your dev station. So that's not a lot, right? But you know what? It's actually pretty, you can get away with that. 16 gig grand total on your machine. Never used 60 gigabytes on anything ever. I know, right? And that's my machine we're streaming. So we've got OBS running, right? OBS is running. We got OBS here. And we're also doing GPU stuff. So, I don't know. I know model. I know. Which one is it? It's this one. There we go. So we called it module, right? Because src, this is module. So this is the module file, right? So we get the module file. So it's create module and then model config, which is a little annoying because I think it should be just called a model. We can just call it model either way. Hey, Loons, good to see you. Welcome on in. Happy Sunday. Good to have you here. Torva, you as well. Real quick, got to go and have appointment with your tailor. What? Tailor? Wait, are you fancy? You're fancy, Torva? You're fancy. That's crazy. Hey, Monkey D. Luffy, good to see you. Welcome on in. Happy Sunday. Hey, Stephen B. Kaga, good to see you as well. Welcome on in. Happy Sunday. Got to do some work. All right, let's do some work. You're going to be my background music. Sounds good to me. Sounds good. That's what I do as well. I watch a lot of live streamers. I do. And they are usually there to help me fall asleep or just hang out in the background as well. So I understand. You have 4 megabyte VRAM usage right now. 4 megabyte VRAM. That's actually pretty decent. That's pretty decent. Don't scream too loud, please. Okay. Will do. Hey, Bros, good to see you. Happy Sunday. Welcome on in. We're going to be doing some Rust, comparing Rust to Python. Is Rust going to be faster than Python when it comes to machine learning with PyTorch and the Burn library? We're going to find out. We're going to find out. So let's see. Let's do, we're going to say type my backend equals. We could do that up here, right? Type my backend equal. Oh, it's an assignment. So it's going to be WGPU. We can't do assignments outside of WGPU. And then an F32 and an F32 maybe? A double F32? Oh, an I32. Why? Why? That's crazy. Good to have you guys here. Numfile, good to see you. First thing should be AI Rust series. Make byte pair encoding. Ooh, we could do byte pair encoding. That sounds good. Yep. It's going to happen. It's going to happen. So we're going to learn all the Rust burn library. We're walking through that right now. That's what we're doing here, you guys. Device default. Okay. Device equals default. I don't have this default here though. Is this gonna work? Is that gonna work? I don't think so. Default, right? DEFAULT and default. I don't know if this line of code is gonna work right here. This seems wrong. This seems wrong, you guys. 16 gigs and you have 80 nothing. Obvi, Rust is faster, right? Yeah, it's going to be faster. I think so, right? But is it faster enough? Is it 10% faster? That might be worth it. That might be. Hey, what are we doing today? We're gonna be learning more of the Burn library. So we're going through the Burn tutorials. The Burn is a deep learning framework for Rust. We're gonna get a familiarity with Rust first and the Burn library, and then we're gonna compare PyTorch to Burn and see which one's better. That's what we're gonna do. I think so. Looking good. Good plan for me. Thanks to Windows. Hey, Stephen. Hey, Neon Java. Good to see you. Happy Sunday. Welcome on in. All right. So where are we at here? We're gonna print this out. La la la. So we got a back end. Okay. Is this gonna build? Build. Are we gonna build there? No, it's got an error. See, I told you that was weird. Right here. I'm like, hold on, can I associate function with, right? So it's missing a thing. Self-type as default? See, there's something wrong here. I immediately knew that was gonna break. I immediately knew. Hey, Google, good to see you. Hey, Tashcash, good to see you as well. Happy Sunday. Wait, NumFile was originally built in Rust. Oh, was it really? Tick-tocking Tinker. What is that? We're using WGP for machine learning. Yes, we are, Bonzupi. You got it. We're going to try. This line of code right here in the tutorial isn't even working. I knew immediately. I'm like, hold on a second. That doesn't make any sense. We found 2 bugs so far in the tutorial. We found 2 bugs. Makes if you try Linux LARP. I can see that. Okay, let's keep going. So we've got our device and the default. And is there anything else we're missing? Oh, wait, we are missing this. We're missing this. Okay, so maybe use burn, backend, and we're gonna say WGPU. Like that, right? Okay, looks good to me. All right, let's try to build. It's still a problem. No, is this gonna break immediately? Immediately it's gonna be a problem. Immediately. You meant to say tick tokenizer. Oh, the tick tokenizer. Got it. Yes. Byte pair encoding. Uh-huh. Hey, Donut Dude. Good to see you. Welcome on in. Happy Sunday. Good to have you here. All right. Tick tokenizer, you guys. Steven just saw a reel about an error large language model. Are you aware of it? No, I have no idea. Tashcash, what is that? Is it like a really good, fast, new, modern approach? You're looking through your old files and saw a virtual machine called Arch Linux. Kill me? Oh no. Oh no. All right, so is this gonna build now? No. Where is our problem? So wait, this is a warning, unused import. We don't care about that right now. Cannot call type. Cannot call associated function on the trait without specifying the corresponding implementation. So am I missing something? Oh wait, default. Here. What this isn't working and I really don't know why. Is this identical? Yep, that looks the same. That looks the same. So what's wrong with our code? Why is our code not working? Let me comment this out really quick and find. Maybe we'll see. So what do you know? So what do we know now? Don't know much Rust. There is a bug in tutorials. Oh yeah. It seems like there is right now because obviously it's not. I mean, it could be me. I called it right here. I'm like, look, we don't have anything default here. See, look. There's something about default here. Where is this at? Disable auto-tune defaults. Default feature. Nope. Config default. Nope, that's not it either. Yeah, see, this right here is not going to work. That's not going to work right there. It's busted. To this day, the only Linux distro that you've ever defeated you was Gen 2. I remember Gen 2. One day I'll conquer it. The problem is it kept going on stage 1 instead of stage 3 tarballs. All right, Bonzubi, I see you try to commit. Oh, comment that out in the Python. Yeah, I did. Yeah, you saw that, Bonzubi. I know. Yeah. I tried using a hashtag, the Octothorpe, right? And because I've been doing Python for so long. I know, you guys know me. During your weekends now, Rust by example. There you go, Loons. Let's learn Rust the best we can. Muscle memory, that's what it is. You got it, muscle memory. I need help here. So I'm gonna copy this and we're gonna go to Jiminy really quick. And the burn library the tutorial is busted. It's absolutely busted. Because I saw it immediately. I see it. I see what the problem is. I just need help. I need help and I don't want to wait. So we're going to ask the AI for help. Here we go. Where was that at? Let me see. And default. All right, here we go. Boom. Okay. Paste. Done. All right, let's see if we can get help. Anyone know how to get Linux desktop on Android? Can you do that? Linux desktop. Oh, on Android. Well, you can get a mouse cursor. I know you could do that. Open source Python library that allows you to run 70 billion parameters on your AI with minimum memory. Ooh, large language models. 70 billion parameters. So it's like, it really shrinks it down. Nice. Hey, how's it going there? Cardum Erdum, good to see ya. Mr. Blum, happy Sunday. Good to see you guys. Welcome on in. Classic Rust interface, error happening, default. Yes, this is where we're having a problem right now. Entirely generic because you're using device anywhere else in main yet. Oh, okay. All right. Fine. Sounds good to me. We just didn't follow the instructions. Okay, it was my fault. It was my fault. So let model equals my model config, right? Model config, and we're gonna say new. And we're 10. So this will be, what is my config? Here, let's go into model really quick. Config. This is going to be number of classes, hidden units, and dropout. Okay. So we could do this. This would be 512. Is that what that was? Is that what they wanted us to do? Okay. Init. Here we go. And then my backend. Okay. Init colon. Weird. Really? Oh my goodness, Rust. Give me a break. Give me a break, Rust. My backend. Seriously, they did not have to do this, by the way. This line of code right here is obnoxious. All right, let's keep going. my backend, and we're gonna say ampersand device, so the reference of the device. There we go. Okay. Now let's print out the model. Print the model, and we want it to be in quotes. Sorry, model. Here we go. Excellent. And we'll just type the appropriate keystrokes here. Perfect. Okay. Yep. Semicolon. Steven plus Russ Sergio. Yep. There we go. Happy Sunday. Good to see you, Sergio. Welcome on in, you guys. Do you provide any fellowship program? Oh, all right. So I need your guys' help from an internship perspective and getting a role open. I did chat with people. No one wanted to do it. They didn't. However, I still think I kind of want to do one, and I have some questions for you guys about it. I have some questions. You think? Let's see if we can get this to work now. Cargo build. Here we go. Oh, print explanation because it's a macro. Did I miss that? I did. Print line. Print line. There we go. Here we go. All right. Almost there. Almost there. we're like one step away. What did I do wrong now? Private method. Oh, did I not make it public? Let's see. Init. Do I say pub? No, do I say pub here? How about that? Oh, it's working. It's compiling. Hey, there we go. I'm number 2. Donut Dude, good to see you. Happy Sunday. Burn. We did it. Run. Cargo run. All right, now we should see some nice output. There we go. We got the model output. Hey, there we go. Oh, they can't? Wait, Erdem, do you provide any fellowship? No one wanted to do it. They just didn't. I've been trying. They're like, nah. You want it? No. How about you? Nope. No one wanted to do it. They didn't. They had no desires to do it. Oh my goodness. Okay, now let's write the... See, this is my problem as well with Rust. Like with Python, you get to write just such clean, simple code. And you don't have all these extra symbols and syntax. And the code is more concise, so it's easier to deal with. With this, there's not a lot going on in this. However, look at this right here. Like, come on. Look at what these generics, do we really need those? Do we really make them do it? It would be a bad experience, right? If they begrudgingly accepted and like, okay, fine, I'll do it. Then whoever goes into that role, the internship, will have a bad experience. I don't want that. I don't want that for you. You think an intern would probably want an opportunity to work with someone who has a great teacher and communicator, and think a good applicant would be able to present their ideas as well. I don't know. That sounds perfectly reasonable. That sounds perfectly reasonable to me. Kyle, you got the right idea. All right, so is this in main or my module here? I believe this will happen inside the module. So it's going to be in this file here. Yeah. All right, so let's implement it there. Let's go. Close that. We are going to implement this here. Pub function forward B as the back end because we are crazy. And what do we output? A tensor? All right, so we're going to do a tensor, a backend 2. Why? Right here. This right here. This is unacceptable. Right here. This is unacceptable, I suppose, right? Because it's saying that we have to pass back a 2-dimensional tensor when I don't ever want to have to say that. Unacceptable, Rust. Unacceptable. And it probably is just the burn library, really. That's what it is. It's the burn library. Okay. Forward and self. Let's see. So we don't need that. We need and self. Images. And this is going to be a 3D tensor. Tensor 3D. Okay. 3D tensor. All right. Did we get it? Is that everything? And it returns a 2D tensor. Okay. Let me make sure I get all the syntax right. Self images tensor forward pub forward ampersand images tensor. Looks good to me. Okay. Excellent. You made this skill yourself. Ooh, a skill. You can't get Claude Code just because. Ask me some questions. Full complete prompt. Like that. I like that. Is there other options of libraries other than burn? Burn is said to be the easiest. It's said to be the easiest. Does this look easy to you? Look at that. It's just obnoxious. Don't worry. We're going to make it happen though. You train people and hate it. You do it, you get or do it or you're fired isn't a thing anymore. Well, it is. It's just here. All right, lock in, you guys. Check this out. It's really important. If you're ever in a management role, or if you have to, guide a team or talk to anyone, you don't want to set up animosity. You don't want to set them up for animosity. You want to not lose their aspirations and drive. It's really important. You got to make sure that they are motivated and they're happy, because that's a big part of making everyone else successful on the team. If you take that away from them, it's really hard to bring back motivation, and it might be gone. It might be gone forever. And it's not even fun. It's not fun either. It's not fun for anyone. So it's just a lot better to put everyone in a position where they have ownership and drive and they can make their own decisions. If I take that away, easy, gone, they're done for. We can't take it away, you guys. Can't take it away. All right. I think there's also a candle. It's called convolutional neural network for the reasons. It's convoluted. It's convoluted. Like those convolutions, you guys. All right, let me make sure that this builds. That I did that right. That's correct. Implement B. Model B. We have to do a second. Okay, so we have to do it outside of this. Okay. Sounds fine to me. This is really annoying that you have to do this. Here we go. Implement B for the back end, right? Okay. How about that? Is that good? Obviously, it's going to say, did it want to be an ampersand? No. Okay. We'll keep going. 200 IQ up play. I know, right, Kyle? Yeah. Uh-huh. Talk to someone. Want them to what? You can also raw dog tensors in WGP. You can? Oh, I want to learn that, Von Zupi. I want to learn that. Okay. Batch height width on images on dimensions. Okay. See, this line is fine. This line is fine right here. I'm okay with this. Although I would rather not have to put these in brackets. Batch size. This is called height width. Okay. What about channel? What about the channel? Where's the channel go? Why aren't there any channels? That's annoying. That's just a smidge annoying. B backend. There we go. Okay. You're just guessing? Hey, Fonzupi, we're going to find out. We will, because I want to do it. You can't see a reason why they wouldn't let you do it? I hope so. All right, images, reshape, batch, one height. Okay, so see, I told you there's got to be a channel in there. See, create a channel at the second dimension. I knew it right there. We know what we're talking about. All right, let x equals, this is going to be our variable shadowing here. Images.reshape, and we're going to reshape it with everything inside of this, except for we're going to add a channel right there. Okay. Looks good to me. Did we type that correctly? Looks good to me. Okay. And then we're going to do feed forward on all of our things here. Hey, what are we doing? Hey, how's it going? We're learning the burn library. Once we're done with the burn library in Rust, we're going to compare it to PyTorch. That's what we're going to do. We're going to make our way, you guys. conv1 forward, let x equals self.conv. conv1.forward. It's annoying that I have to say forward because in PyTorch, with Python, you don't even need to say that. You can just execute this directly. You should have a call. Why did you not implement this burn? I think that's something that you could have done. I think so, unless maybe you can't. I don't right? Forward x. Okay. This is going to throw, and then we're going to throw it into a dropout. Okay. So you forget some things during training. So drop out. Do we have to also say forward there? I guess we do. Okay. We're going to do conv2 probably down here. Right here. All right, looks good to me. Okay. See? No? Right? Exactly. So good. I like you got some Python there. You got some good Python there. So clean, easy to read, even if it's on a bunch of different lines. Like, it's so much better. It's so much better. All right, we're going to do dropout again. A little bit extra dropout. Just in case you didn't have enough. Now we have more. And then we're going to use our activation. Activation. Looks good to me. Okay. La, la, la. And then we're going to do a pool and another reshape. So that way we can fit it into our linear layer. Right? It's got to be fit into our linear layer. It's got to match this dimension here. Right here. It's got to match that. So pool. Let's do the pool here. Thank you for the hearts, you guys. Appreciate it. Good to have you here. Happy Sunday. And then we're going to reshape it. Let x equals x.reshape. And this is going to be another brackety bracket. Thank you for the hearts. Appreciate it, you guys. I see it happening. Hello, Mr. Sheldon. Cooper. Oh, Ulap. Hey, Ulapa. Good to see you. Happy Sunday. Welcome on in. Good to have you here. All right. Batch size 16.8. So we're going to say the batch here size. And then it's going to be 16 by 8 by 8. There we go. Done. Reshape complete. What are we coding? We're gonna be learning the burn library in Rust. We're gonna compare it to PyTorch after we are successful having a full grok. Basically, I have a full understanding of Rust. Once we're there, we're going to do the comparison. So it's gonna take a few weeks. It's gonna take a few weeks. We're gonna be doing it every single day. We'll go live every single day and we'll learn a little bit. You're gonna play when it's finished? No, promise actually. Promises. You're gonna play when it's finished. I think so. I think so. Good luck. Thank you. Thank you very much. Here we go. 8. Linear dropout activation. Okay. We can do this. We can do this. Here we go. Linear 1 forward. Dropout again. We get so much dropout. I've never used this much dropout ever. Do you play chess? I do. Yes, I do. Still no touchpad. Oh no, Bonzupi! Still no touchpad. Activation. All right. Boom. Easy. We're going to say X, right? Oh, wait. Whoa. Oh, we're going to just straight up. Well, I suppose we could do that too. What's your ELOS? Like 1,000. It's not good. It's like 1,100. It's 1,100. It's not good. Skill generalized doesn't define your entire understanding. I mean, that's fair to say. I'm with you on that. All right, so we're going to do linear 2. Dropout activation linear 2. So we're going to project here. We're going to project our final output projection. And I'm going to do it differently. I'm going to say return X. So that way it's explicit. So you can see what's going on. None of this implicit returning, which I love because I came from Perl and this was something in Perl and they just decided that's what they're going to bring in. Rust has implicit returns. Did you guys know that? Pretty good. You're 850. Oh, wait. Really? Oh, up. Hey, don't worry. Don't worry. It's my score. I'm lucky. I'm lucky I got my score. Data structures and algorithms. Hey, do you post on Stack Overflow? I do. I've got my own Stack Overflow account. And let's go visit Stack Overflow, you guys. Let's say hi to Stack Overflow. Yeah, here's my account, right? I've been on for 15 years on Stack Overflow. And I got a pretty good reputation score. Look at that. I get to brag to you guys now. Thinking of it, maybe you sound like Sheldon Cooper. Maybe a smidge. Wait, you're in your 20s? No, I'm in my 40s, you guys. I'm old. All right, let's see if we can build this now, or it's going to fail. Oh my goodness. Self-unknown field linear. Wait, did I not name these things? Right here, it's right there. Linear 1 and 2. See? They're so completely there. What do you mean they not exist? Unknown field name. Did I type that wrong? I did. Linear 2? Wait, that's not typed wrong. See, look at that. All right. There's no field linear 2 on the model config. What on model config? Module config. Am I doing this wrong? Oh, I am. Okay. Model. There we go. All right. Making it better. Hey, Neatswalk, good to see you. Welcome on in. Happy Sunday. You look 12. Hey, Plankton, thank you. I assume. Kyle, thank you for the super chat. Whoa, thank you.
Index pointing at the viewer emoji.
Yeah, got our Stack Overflow right here. Let's go, Stack Overflow for the win. Why don't you announce you're live on Discord? Oh, well, sometimes it shows up, sometimes it doesn't. In your opinion, you keep nose and bum ahead. Bum head. Wait, in my opinion is option keep your nose out of bum head. Okay, yeah, sure. Yeah, that sounds fair. Very nice. Do you draw as well? I don't. I just type on the keyboard. That's what I do. Stack Overflow got dead when it started programming. The whole industry flipped. I know, right? I miss Stack Overflow. It's nice to say hi every once in a while. I never go there anymore. I used to go there so much. So very often. Just so frequently, you guys. Okay, where's my text? Thank you again, Kyle, for that. Appreciate it. All right, so I knew it. B, there we go. Okay. Are we good? Oh, look. Hey, there we go. All right. We're learning, you guys. We're learning. We're making our way. Do you help me to learn DSA? Maverick, I suppose what we could do is we could go... Whoa, Kyle! Enabling creative experiences. Automation greater than automation. At Flip with Kyle, you guys. Flip with Kyle. Thank you, explanation party poppers. Oh, Kyle! That's really nice. Thank you so much. I appreciate it. Kyle, you're wonderful. So you were alive in 9/11? Yeah. I remember that day. I was watching TV and then it flipped to the news. I didn't want to watch the news. I wanted to watch my TV show. It was early in the morning and then all of a sudden it showed a building and a plane flying through it. I'm like, what is this? Why am I not seeing the TV show I want to watch? They flipped all the TV channels over to this. Every single one. See right here. Sometimes it's refreshing to see Stack Overflow instead of AI slop articles. Human, genuine human. Yes, what you said, sir. So Maverick, if you have any questions, let me know. Just let me know. Also connect with me on Discord. Olapo, I know, right? Is it crazy? All right, we built it. It's running. All right, let's try to run it. Cargo run. Hey, look at that right there. All right. We're making our way, you guys. We're making our way. So I've modified mine slightly. You remember 9/11? You were 6 years old. You didn't understand or care about what you wanted to watch JJ the jet plane on PBS. Hey, there you go. Right, Bonzupi? Exactly. We had the same experience. I was watching a different show, though. Can you give me a life advice for success? Keep going. Just keep going. Also, don't prepare for something. Just jump into it. Unless it's, a dangerous situation. Just start. Whatever you're doing, just start doing it. Just go. Don't, get ready to get ready. Just start immediately. For example, I feel like I want to learn how to program, or I feel like I want to learn this library, but I need to get ready for it before I can use it. Don't do that. Just use it. Just use it. You were 17 years old? Yeah. Hey, yeah, I was Bonzupi. Yeah. Well, I was around that age. I don't remember my exact age, but I think I was about that age. Yeah. Thank you, Mr. Blum. You're welcome. Advice, legit advice. All right. So now that we did that, what's this here? Tensor B is a float tensor. They really need to describe what this means. This to me tells me it's a 3D tensor, right? It's a rank 3 matrix, right? Or something like that. How hard is it to use the burn library? It's a little challenging because look at all these fun symbols that you have to throw all over the place. Also, you have to type the word forward when you want to call a method right? When you want to feed forward on a layer, you have to actually call the word. You have to call the method forward. And if you want to define. So it's like, it's just extra. It's just extra code. Look at all these forwards in here. It's like extra code. It's extra. Have you heard of the Malcolm in the Middle? I have. I watched it. I've seen it. That was when I was alive. That was my show. I like that show. Indeed, I am Bonzupi. All right. Yep. There we go. Okay. So note that the specific element type of F16 and F32 and the like. Float, int, boolean, tensor, and int tensor, and a float. All right. So that's interesting. All right. We're learning a little bit more, you guys. So wait. Do we actually get to use the library that we wrote? Or are we just stuck? That was the end of it? No. Well, okay. It was a good exercise. I would be nice to be able to use it, though. How old would you have guessed I was? Like, let's see. Well, I guess you're in your 30s? Bonzupi? I suppose right now. You're in your 30s? I'm guessing? Do you have a Nintendo Switch? I do, Kyle. I do. Yes, I have the first Nintendo Switch. Like in the 22 to 30 years range, ain't you? Are you 42? I am in my 40s. You got it. I'm in my 40s. What are we programming here? We are programming the Burn library in Rust. We are learning all the different things that we need to learn for the Burn library in Rust in order to be successful in comparing Python and PyTorch to Rust and the Burn library. Which one's faster? 31? All right, we got close. Cool, yeah, I think so too. Okay, let's keep going. All right, so we're gonna type all this out now so I understand what's going on here. Images, items, so we're not done yet. Oh, we have to do data loader. No! Okay, fine, we'll do data loader, we'll do it. All right, source.data. All right, here we go, you guys. Source data.rs. I'm glad we're not done yet, though. I'm glad we're not done. All right. Use burn. And we're going to keep on typing this in here. You're 37. Hey, Slick. Good to see you. Welcome on in. Happy Sunday. From San Francisco. Hey, I just moved from San Francisco to Seattle. Crazy world. Feed forward. I know we completed our feed forward. Yeah, we did. We complete Bonzupi. You got it. We just finished it. So now we're going to do data loading. Are you a game developer for a big studio? I am. So those of you who are new here, my name is Stephen Blum. I'm the CTO at PubNub. We raised $134 million. I started this company over like a decade and a half ago about. Series E, 1 billion devices on my network, 68 patent claims granted. You can see them right there on my LinkedIn. That's real. Also 31. All right. Let's see. So big studio, I would say we're a pretty big company. We're pretty big. We pull in lots of monies. So we do pretty good. All right, let's keep going. Where are we at? Yeah, okay. Data loader batch. All right, let's see. Data loader. And we can say batch. Was it capital B? Yeah, batcher. All right. And then batcher, probably. Batcher is how they usually do this. Data set. Vision imnist. Oh, hey, all right. That sounds good to me. Vision imnist item, right? Okay. And then we're gonna do prelude, star, everything. Star it all. Okay. All right. We're gonna have a batcher. Whoa, Steven's the real deal. His business is huge. Yeah, we did good. We're doing good, Kyle. Thank you.
Steven is the real deal.
Just give me $10 for a snack. I know.
Yeah. Celebratory hands in the air emoji.
Thank you, Kyle. At Flip of Kyle. Thank you, Party Popper. Appreciate it. Very nice, Kyle. You're giving me so many amazing adventures. Thank you, Kyle. This is great. Many donations. So many. My gratitudes. How do you ping people? What do you mean? What do you mean ping people? At our company, we use Slack. For example, drive clone default. Okay. Clone and default. La la la. And then we're going to say mentions their names. Oh, the at. Yes, at. The at sign. At someone, yeah. Stuck with writing down names and pretending I ping someone. The at. Yes, you just do at. So, right, like this at Olo. Like that. You don't do English, Rakesh? Well, good to have you here, even if you don't do English. Pub struct imnist batcher. Pub struct imnist batcher. Okay. Then we're going to wait. This is the same thing here and here, right? These two are exactly the same. Or do we have to do separate things here? Next, we need to actually implement the batching logic. Okay. That looks identical to me. So I assume we don't do this. I mean, this would be weird. Batcher, right? That looks odd. Oh, backend, sorry. Let's see here. What is this? What is this? Humans, yes. Coding, exactly, you got it. Coding. Backend. See, this is weird. I'm pretty sure we have to do this. Keep it like that. And then we have to implement it now. Pub images and targets. Pub images. And the images is going to be a tensor rank 3. Tensor B rank 3. And then we're going to have targets. Targets. Rank 1, was it? Rank 1. And they're going to be integers. There we go. Perfect. Okay. Looks good for me. Okay. Now we have to build the batch itself, which I mean, come on, look at this. It's like homework. It feels like homework. It's just so much extra work. What is B? B is a generic for the back end. It's going to be the accelerator typically, right? So WGP is what we're using.
Blum for president.
Whoa, Blum for president. Well, I'll be vegan and despair, right? No meat for you because it's damaging the planet. You're going to eat. See, it sounds good. Oh, Oppa. U.S. government. Kyle, thank you again. Kyle, you're great. You're wonderful, Kyle. At Flip with Kyle, you guys. Flip with Kyle. Flip Profit. Flip Profit. Thank you. Again, with some party poppers. Could do some poppers. This is like the common gratitude. Thank you, Kyle. Appreciate it. That was so nice for you. That was really great. Thank you. All right, so let's implement. Look at my goodness. My goodness. Look at this line right here. Doesn't that I mean, you don't have to do any of that in Python. None of it right there. This is humans are very happy. You're very happy. You got it. Implement. We're going to say implement with our back end here. Back end. Batcher. Batcher. Wait, did I define the batcher? I have the imnist batch. That's a struct. Oh, imnist batcher. Here we go. Okay, imnist batcher. This is the imnist batcher. This is the imnist batch. Okay, so this is like a single item maybe. This makes sense now. I was reading it wrong. You've been going dairy free. Oh, that's a good way to do it. Dairy free sounds good. Okay. All right. Batcher B for backend. Imnist item. Imnist item. And then imnist batch. Imnist batch B. Great. Okay, great. Look at this. It's crazy. For imnist batcher. Okay. Excellent. Excellent. All right. You haven't eaten meat in 10 years? Bung Zoopy. Yeah, there we go. Yeah, me too. Me too. It's been a long time. Bun Zoopy, we're on the right track for staying away from voluntary illnesses. All right? If you eat healthy, you will not elect to voluntary illness. Loons, you love Codex. Hey, me too. It's a good one. I like Codex. I like anti-gravity, Google CLI. I like Codex. I like Claude. These are very great tools. Sunlight is very important as well. Exercise. I mean, the food you eat is so, Brian Johnson, 90% of his health regiment is eating healthy. And I think that's like the most critical item, right? He works out too, right? He works out, stays out of the sun, does not go in the sun. Let's see. MNIST. All right, so where are we? Implement. All right, did this here. We did this crazy line, which took like 3 minutes to write. We're going to write a batch function out. Function batch. Self. There we go. Items vec MNIST. Vec MNIST item. Okay, it is a vector of MNIST items. Okay. Device is going to be our and backend. Device. Okay. We're going to arrow a MNIST batch. MNIST batch. My goodness, you guys, that's crazy. This is crazy. I have so much high likelihood of mistaken typed items. Let images equal item. Now we have to do a whole bunch of weird stuff here. Your diet about your health. Yeah, all right, got to get that health. Oh, yeah, don't smoke. Smoke is, yeah, there we go. Burn again, Neva. Hey, burn, yes. So, Neva, I want to learn the burn library as well as we've learned PyTorch. I am very comfortable with PyTorch now. I want to learn the burn library, and we're going to compare them. We're going to compare the two. Stephen, Lord of Light, calls thee. Hey, that's it. Fish is necessary for us, right? Hey, Jay, bro, yeah. Fish is good, I assume. Oh, I don't eat it, though. I just eat beans, you guys. I eat beans. Iter? Really? Are we iterating here? Dot map. All right, so we're going to do some data conversion. All right, so we're going to get our item as our variable. This is our lambda, right? We're going to do a lambda here. My goodness. This is just too much. It's just too much. I don't know if it's worth it. Like, immediately, I can tell you it's not worth it. It just feels not worth it. Tensor data from, was it image? Item.image. Item.image. Dot convert. Really? Okay, really? B float element. Float elm. See, I mean, LM or LM, sure. Okay, LM. Why not just call it LM? Okay. Okay, and we're going to do another map. Hey, Mark Lemon, good to see you. Welcome on in. Happy Sunday. Good to have you here. Burn creators are just lazy. I know, Rocks. Look at all of these, like, you have to, they put all of the exterior of the library on the end user. Steven's not even faster. Like, it ends up calling dynamic crap the exact same way. Does it? See, that's what we're gonna try it out. We're gonna try it out. We're gonna see what it's like, and once we're ready, we're going to go back to Python. That's what we're gonna do. That's probably what we're gonna end up doing. That's the plan. Sketching an idea for interpreted systems language. Ooh, sounds like you're doing some fancy. Data tensor. Okay. Map. We're gonna do our data. And then we're going to do another tensor data. No, just a tensor. Not tensor data. What's the difference? I have no idea. A rank 2 tensor. All right, I understand that part. So we're starting to see some things that we memorized here. From data. Data? Do we have data? All right. And device. Okay. This is going to take the entire time, isn't this ridiculous? All right, then we're going to reshape it. Okay, so I see what's going on here. It's just that I would rather read it. I'd rather read it differently. Like, I just rather read it differently. They're for sure not lazy. Rust is just bad for AI. Okay, yeah, I could see that. Yeah, I could see, because there's just so much math involved in AI, right? And it feels so much extra effort to have to add all of these extra non-AI related terms into the mix. Like, look, there's 2 giant lines here that have very little to do with the actual AI. Hey, how's it going there? Cordioro. Hey, good to see you. Welcome on in. Happy Sunday. PyTorch already incredibly optimized, right? We're probably going to go back to PyTorch is my fast. Yeah. And then we're going to start building some amazing things. That's what we're going to do. Right now, we're going to try out Rust for a few days, at least. Hey, good luck, givers, takers. Welcome on in. Good to see you. Happy Sunday. Good to have you here. All right, let's do a reshape. Map. And we're going to call this a tensor. All right, tensor. And we're going to do a reshape, tensor.reshape, right? Probably, yep. 1, and then this is 784 because it's MNIST. And we always have to put these in brackets because they like it, like brackets. Okay. All right, we finished that line. Now we do a tensor. Then we do, okay, so we do some norms here. Got to do a little bit of norms. At least I know what's going on here. I recognize this pattern. It's less that PyTorch is more or less optimized. Burn can call PyTorch. It's a CPU code, doesn't not matter. Okay, there we go. Hey, having fun? Yep, there we go. We're having fun. We're having fun yelling at the syntax. That's what we're doing. Tensor, all right. Dot map. We're going to say a tensor. And then we need to do a whole bunch of things in here. Okay. Tensor, all right, so we got to normalize, divided by 255. Do we want to make that a float? I guess it doesn't matter. All right. And then we're going to shift it. And these shifting numbers are very specific. Let's see here. 1307. 1307. And divided by 3081. Okay. Do we have everything in the right spots? Right there. Okay. Looks good to me. Looks good, looks good. Hey, how's it going there, Joy? Good to see you, Joy. Welcome on in. Happy Thursday, Sunday. Rust does that part at least slightly better than Python. Yeah, the CPU part for sure. We can all guarantee that Rust is definitely gonna be faster on that side of things. On the data processing part. The part that we're actually typing out right now, it'll be faster for sure. You can also do proper async, which also matters. Oh, proper async, yeah. So that way we can do some better parallel processing. Point it to matter. Okay, yeah. All right, so collect. Collect. All right, did we do it? We processed our images here. All right, I see what's going on. I understand. Here's the good news. Here's the good news, you guys. By doing this process right now with what we're doing with the Burn Rust library, it's going to cement a lot of our knowledge that we learned in PyTorch as well. So it's good to go. We're making things happen. Hey, Ollie, good to see you. Happy Sunday. Welcome on in. All right, targets. We're going to do this. Oh, wait. Do we want to indent that a bit more? There we go. Just to make it a little bit easier to see what's going on. Let targets equals. All right, so this is the output, right? This is the output. We're going to get the classifications here. Dot iter. Dot. Are we going to map these? Yeah. Map. Okay, I see what's going on now. I'm getting it better. I'm getting it better here. Item, which is going to be the image, right? Why call it item? Why can't we just call it image, right? Right? Feels like a good idea to me. Then we're going to do a tensor with a rank of 3, was it? No, rank of 1 with an int. Oh, right, because they're targets. The tricky part, you offload to C++. Yeah, there we go. Tick token is just a fast tokenizer, right? Got data preparation, a big deal specifically for transformers. It is, there's a lot. The good news is you can prepare the data once for the most part, right? And let it run. So it doesn't really matter if it's that efficient. All right. Colon from data. Okay. From data. And then a whole bunch of brackets. Item.label. Item.label. It's already got the label for us. I64. And then, my goodness, Rust. My goodness, look at this code right here. That is just obnoxious. It's just obnoxious is what it is. Crazy. It's crazy. Int lm. It's ridiculous. Ridiculous. Like, come on, really? Device. All right. I hope I typed everything right here. Okay. Dot collect. Looks good to me. Okay. Images and targets. Let images equals was it tensor? Cat? Oh, concat. We're doing a concatenation. Okay. Images 0. I don't know why. I don't know why. Labels. Right. And this is going to be targets, right? Targets. I'm guessing. Labels. Okay. Blah, 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 blah. Targets that... Wait. Targets. Targets. Sure. Fine. Okay. All right. So we're doing variable shadowing here. Okay. We're going to say imnist batch return. We're going to create a new... I'm just going to say return here so we know what's really going on. Images and then targets with a semicolon. There we go. Okay. Did we do it? I don't know. We're going to find out. Oh, no. Wait. I think the file's just not included anywhere. I think the file's just not included. So src main. I'm going to do data, probably. All right. I told you. I knew it. I knew it all along. I knew it. Let's double check that I got everything. Okay, good. So let's go through one by one and fix the errors. Convert, probably. Is it convert? It is. It's convert. Okay. There's the first one. Targets. Items. No, it's item. It'll be item. Yeah. Let target item. Oh, here. Item. Yep. There we go. Okay. One thing at a time. Can Python and C++ be used together to reduce hardware requirements? Yes. Yes. You got it. You got it. Exactly. You got it the right idea. What does imnist batch do? This is going to be like a set of images, basically. So it would be like 10 images, for example, all in one structure. Good question, by the way. Good question. Thank you, guys. Keep them on coming. Good to have you here. Happy Sunday, everybody. All right. Now, let's see if we can build this. Okay. Plus there. Could not compile. Expected 1 of 8 positive tokens. Did we do this incorrectly? B1 int. B1 int. Oh, okay. Sure. Fine. It's got to be that way. I missed the colons. Okay. Hey, there we go. All right. We're on the right track now, aren't we? We're making the way, you guys. We're making the way. All right. Let's keep going. No stopping. We're going to get this thing working. We're going to get a functioning CNN, and we're going to see what it looks like. Are we not? Is there no end? Okay. See, every time I come over to the burn library from PyTorch, I'm like, I just want to go back to PyTorch now because it's just so much easier for the developer. They could have done this. All right, our model. Now, where do we do this? All right, so we're going to create a new file now called source training. Forward classification. Okay. All right, here we go. Vi source training.rs. And we're missing a bunch of headers. It's not going to know what to do here. My goodness. Are you kidding me? Are you serious? Steven, do you want to instead our own Rust library for machine learning? Would be more fun? That would be more fun. It would be, yeah. That would be a good project. And I would not force anyone to add all of these generics everywhere. We'll get to play with some unsafe Rust code. Yeah, I suppose if we're submitting it to the GPU, right? Like hook into PyTorch. Oh, that would be okay. So then we can bring our Rust into PyTorch directly. Oh, I see what you're doing there. Okay, let's think about that. All right, so let's just start typing in here. Implement B backend. There we go. And then we're going to say our mod. So I believe model is probably going to be fine because we've already defined it, I assume. I just don't. How is it going to know? How is it going to know? We're going to find out later, probably, is what's going to happen. Right? We're going to find out later. Forward classification. Yep, okay. Here we go. And it's going to return something, probably. It's going to return a classification output. Classification output. Which we've not brought in, so we have no idea what that is. Okay. Looks good to me. Okay. And self images, and it's going to be a tensor with a rank 3 and a images and labels, maybe? Targets. Fine, we'll call them targets. Targets. Targeteses, which is going to be a tensor rank 1. Yeah. Tensor B1 integer. Okay. Is that it? Okay, good. How's it going there, Pedro Games? Good to see you. Welcome on in. Pedro Gomes. Burn is too many traits. It's got so many traits. It's crazy. You got it. All right. Let output equals self.forward. And then, see, this does not feel like it should be in a separate file. Like, it doesn't seem, it feels like this should be in the model file. You like traits, but jot when abused. Oh, but not abused. Yeah, traits can be really powerful. In this case, I feel like I'm being, it's being shoved in my face. You love Ryan. It has a lot of trait. I'm not familiar. Oh, Rayon. Okay, got it. Rayon. Images. We're gonna have our loss. All right. This is like one step. Is this one? This is one forward. Forward classification. Really? We have to set a separate forward function. Cross entropy loss. Config. Great. All right. New. Okay. I'm going to say init output device dot init output device, which comes right here. Okay. Dot forward. My goodness, you guys. My goodness. Output clone. We're cloning. This is supposed to be we're supposed to be fast, you guys. Why are they doing cloning? Yeah, me too, Bonzoopy. Traits, yeah, I know it, yep, But have a vec usize for shape. Yeah, see, that seemed fair. I like that. That's fine. That's clean and easy. Target.clone. We're cloning, you guys. We're doing efficient stuff. We're not really doing efficiency here. Cross entropy. What is it? Oh, classification output. And we're going to say new, and we're going to say loss output targets. Okay. Loss output targets. Return. So we can see exactly. Nerd. Yeah, you got me. We all got the nerds. That's the answer. You got it. We're the nerds, you guys. My goodness. All right, let's keep going. Maybe some of this will sink in. What's going to sink in is my appreciation for PyTorch is what's going to sink in. All right, Steven, stream. Do a stream where we make our own PyTorch beings for Rust. Bindings. Our own PyTorch bindings for Rust. It will be more fun. That sounds like a lot more. Yeah, exactly. Neva, we'll make it. Come on. All right. Let's put it in the ideas. All right. Stream ideas. All right. Here we go. Rust bindings for PyTorch. So we can build a DL with better ergonomics. Some better ergonomics. Rust, Python, post. Okay. Boom. Done. Added. Hey, that Vasper. Good to see you. Happy Sunday. We're doing the burn library in Rust. And we are yelling at all of the abstractions because there's more abstractions than there's actual code, which is unforgivable. It really is. It's unforgivable. The amount of abstractions they've got here. Finished with Rust programming language book. Hey, very nice. I like Rust. It's just that you can get too abstract with it and it gets overwhelming. We're doing that right now. We're being overwhelmed with couple of small projects to get used to Rust. Nice. Actual useful library. Yes. That would be really good. Okay. So we're going to do an autodiff backend. I believe in the same file probably. Implement B autodiff backend. This is unacceptable. This is unacceptable. Burn library. I disagree with you. Step. For model B. There we go. Okay. You want to beat yesterday's record? Ooh, loons! You think you could? You got the 950. You got the 950 yesterday, remember? Okay. We're going to create some types here. Inputs. I'm not satisfied with this, you guys. I'm not. Mnist. Batch with our back end abstraction. Great. We're going to have an output here. Outputs. I guess I like to pluralize things when I don't need to. Classification output. Classification output. There we go. Okay. We're going to create a function, step, and self probably. Batch. This is going to be an mnist batch. Mnist batch. There we go. With more backend trait right there. Hey, Rag, how's it going? What language is this? This is Rust. This is Rust, which I like Rust, just not when it gets overly abstract. And then I get angry. I get disappointed is what I get. I get motivated to do something else. Ooh, 2D games. Yes. Learning Lua. Lua. There we go. That's a great language, right? Okay. Did we do everything here? Training output classification. Sweet goodness. Training output. Output. This is something I'm not familiar with this one right here. And this will be classification. Output. Yep. With extra goodness. There's not enough goodness in there, so we had to add extra symbols. Got even more symbols. There's not enough symbols. Oops, I must have deleted things that I didn't mean to. Okay. We'll just retype it. Classification output B. Okay. Item forward classification. Let item equals self dot forward classification batch dot image. This is the images and targets. Okay, batch dot images batch dot targets. Function is that Rust? You got it. Yep. Jaden, you got it. This is Rust, which I like. I like Rust, just not when there's a lot of extra syntax. All right. I think we're gonna get most of this typed out at least. Love 2D for 2D games. The library is cool, called Love 2D. Nice. That's a great name for a library. Read my comment. Rag Kumar. All right. Where'd you find it? I want to be really full stack developer. Node.js is good for not or full stack developer. And what you do with Rust. Rust, you can also, it's for the backend, right? You can also do full stack on Rust, right? Rust is great for performance and reliability because it's got built-in safeties, type safety, memory safety, and concurrency safety, things that other languages really don't bring. Rust does, and it does it at compile time. That's why it's special. That's why it's great. It's one of the greats. Rust is overhyped. I don't know why. It is overhyped. You're right. It is. However, I can guarantee you that it works as advertised. Please, 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 Steven, let's use the PyTorch bindings for Rust someone already made instead of burn. Oh, Neva, you're watching Steven suffering through this? Wait. Okay, wait. Let's think about that. Okay. Do you have a link, Neva? Do you have a link? And I'm just complaining, and I'm complaining about this, which we'll get through it. Oh, Torch. Yes, that's been out forever. TCH Rust. This has been out for so long. This is like the first one. Rust bindings for the C++ API of Torch API. The goal, provide some thin wrappers. Aims to staying close to the possible of the original C. Okay. So it's going to give us an example. Ooh. Hey, that's a lot nicer. I like that right there, Neva. Yeah. Okay. Are we going to change it up? Are we going to change midway? Wrestlings. Yep, we're getting some wrestlings here, you guys. Is the CEO pubbing up? Oh, I am the CTO. So I'm the CTO, and I believe, where is that? Here, zoom out here. Is Todd around here? No, here, let me see this. Here, I'll show you. T and Greeny, I think, right? Probably. Nope. All right. Let's see here. Green. Here we go. Perfect. Okay. And here's the CEO pubbed up. Todd Green, you guys. You know Todd. Cargo install Rustlings. Ooh, what's Rustlings? Rustlings crate. What's the Rustlings crate? All right. Rustlings crate. What is this? Small exercise to get used to reading and writing a Rust code. Oh, nice. Okay. We're gonna switch over to Torch. We're gonna try to switch over to Torch. I don't know if it's possible. Let's see if there's a website that we can get back to our tutorial. There's no website. Where's the button to click? Where is the tutorials? You guys see? I see documentation, but that's usually not what you want, because it's just going to give you the implementation references. I need some tutorials here. PyTorch website download section. PyTorch. Is this... Am I going to have trouble with this? This is a lot nicer. Hey, Neva, look at... See? You're right here. Neva, you're right. This right here. Let's do it. Okay. But Steven, it's literally just PyTorch. This is so much nicer. Look at right here. See the screen? Do you see any heavy abstractions listed in here? No, you don't. Burn is ridiculous. This is great. All right, so you made my day way better, Neva. Thank you. Okay. So we're going to switch over now into saying goodbye to Burn. Look, Burn is supposed to be easier. It's not. It's not better. Look at this. This is way better right here. This is hands down way better. Thank you, Neva. Are you back-end developer? We're all end developer, omni developer, every end, front end, back end, side end, data science. We did it all. We've done it all. We're now going to get libtorch running on our computer. Are you guys ready? Goodbye, Burn. Goodbye, Burn. See ya. Wave bye to Burn, everybody. Bye, Burn. Sorry, you're too annoying, Burn. CD. All right, so we're gonna say mkdir rust tch. We'll do rust torch. How about torch? Rust torch. CD rust torch. There we go. Bye, Burn. Bye, Burn. Sorry, you're too annoying. There's better solutions out there, T-Mux. All right. Guys, you still here? Yep, we're still here. For a little while longer. Okay, so I have libtorch on my computer, obviously. I have libtorch. Let's see. I have tried to do this in the past, and it was quite difficult to get it to operate. Libtorch use PyTorch. So let's see if we can get this to build. So let's clone this repo. Let me see here. Path to libtorch. Where would my path to libtorch be? Okay, we're gonna figure this out, you guys. We're gonna figure this out. If you prefer temporary environments, no. Where's my libtorch at? We don't know. What's the Omni developer? I've never heard of that before. It's you do it all. You do everything. right? Data science. We do front end, back end. What else? I mean, maybe that's it. Is there, well, DevOps, right? There you go. DevOps. That's a whole other discipline right there, right? Security as well. Yeah, building C++ is not necessarily fun. That's true. Bye, Burn, right? You burned us enough. I know. Goodbye, Burn. Look, this sounds so much better right here. See, this is what Burn could have been. Burn could have been this right here. Look, it fits all on the one screen. The whole thing. Simple neural network. Here we go. Let's do this. Let's do this. All right. TCH, Rust, Torch, TCH, right? Create. Tier 8. Great. Okay. Here we go. So wait, there's two. Well, oh, this is the crate. Here we go. Let's go to the crate. Okay. Getting started. The crate requires C++ PyTorch library, libtorch version 2.11. Okay. Use the system lib libtorch installation. That's the default. Okay. We're going to get this running, guys. We're going to get this running. System wide. Export. See here, this is unfair because where does my... All right. Where is my libtorch? Okay. Where was that at here? Around here. All right. La la la. Where is my libtorch on Mac OS? I don't even know where it's at. Do we have to do some extra installations here? Oh. All right, there it is right there. Okay. So that made it easy. Oh, EA, even better, all in one. Perfect. All right. ZSHRC. Okay. Boom. Easy. There we go. It's gonna take. The problem with this though is it's going to slow down. It's gonna slow down. I don't want to slow down. So every time I open a new window. So 1 second. We're just going to manually code it, and for now, I like this idea way better. Here we go. You know what? Export libtorch equals. Perfect. Okay, there we go. Nice. Bravo, Jayden. Yeah, we're making it. Okay, here we go, you guys. Okay. Thank you. Libtorch found. Easy. Now, can we use MPS? Is that going to work? Where's my... So we've got a problem, you guys. We've got a problem here. All right, here we go. So let's create cargo add TCH. Let's do that. Okay, so close, open tmux. Let's do env grep. We're going to say this was libtorch, right? Right? Libtorch. There it is. All right. It's available. Perfect. Okay. So cargo new my first TCH. CD my first TCH. All right. Cargo add torch. Done. Cargo build. All right. Looking good. Steven, you need to make sure TJ3 version matches. I would make a Python inf specifically for libtorch for Rust. Yeah, so it wanted 2.11, right? It wanted 2.11. So you're right. I need to do that. Okay, so let's do this. Okay. So I'm going to create a new VN. So deactivate Python-m VN. Wait, I forgot, what was it? Python new VN. What's the command for this again? -m. Okay, got it. I just gonna say VN. There we go. Okay. Now let's do source vmp. We're gonna say I want bin activate. Okay. Then we need to install a very specific version. Pip install PyTorch 2.11. Full stack, there we go. What's an Omni developer? I know, right? What is it? An everything developer, not just full stack. You know, I think full stack is probably the closest thing that you could say what an Omni developer is. Okay, here we go. Hold on. Did we type that wrong? Oh, wait. Oh, wait, hold on. Okay, copy this. Let's try that. Okay. Couldn't find anything that matched. Okay, 1 second, you guys. 1 second. We're going to figure this out. Ooh, this is a good test right here. Yep, not exist. Okay, good. Okay. PyTorch install. Let's go started. We're going to do a pip install. Well, that looks fine to me. The only problem is, I think we'll just do this. Here we go. You're using... All right, what's wrong with this? You guys? You see? Why not using UV? All right, let's do UV. I have UV. I believe I have UV here. UV. Yep. All right, so we'll try UV. Package, libtorch, source. It doesn't give me an option for UV. I don't see an option for UV. Sudo apt-get install PyTorch. Easy. I know, right? I know. See, 310 to 14. Good. Python version is 396. Okay. So I need to install 314. Maybe we'll do 312. Python VM with 3.12. Okay. This is what we need right here. Okay, perfect. Okay. Deactivate. Actually, let's close that out real quick. Deactivate. rm-rf vm. And then we're going to say vm python. All right. Python-m, Python 3.12. -m vm. Like that. Easy. Okay. Source vm bin activate. And then I want to pip install some stuff here. If I do this, let's see. I don't know if it's going to give me the right version or not. Let's find out. It gave me 212. It might be a problem if I do 212. Hey, Maverick, good to see you. Welcome on in. Happy Sunday. All right. Let's see here. Okay. Let me double check. All right. Well, hold on a second. Python version. Yep. All right. 3.12.12. I didn't know. All right. Sounds good to me. Okay. Let's do a quick little test here. We got some backends available. MPS available. True. All right. Looking good. All right. Jaden, thank you for stopping on by. We're going to get what we're going to do. So the plan for today, for the rest of today is we're going to get our local installation for PyTorch Rust bindings to install and work. I knew that was going to be a struggle. The good part about Rust and Burn library is it just kind of worked. However, the Burn library is just so annoying to use, isn't it? It was so annoying. So instead, what we're going to do is we're going to take Neva's recommendation and we're going to be using the Torch library in Rust instead. Now, in order to do that, we have to get the environment set up properly or else it won't work. So let me see really quick here. Okay. Okay. Let me go back to this really quick. Is there a way to see what I've done previously? There we go. Okay, I want to do this again. So that way I double check that it's in the right spot. Because it's going to be somewhere different now. Yeah, here we go. Perfect. Okay. Copy that. See, it's in different directory now. So we need to copy and paste this. In the ZSH, here we go. RC. Different directory. There it goes. Right there. Virtual environment. Excellent. Love it, love it, love it. Why not use libtorch in C++? We could. I wanted to do it in Rust. It probably would be way better to do it in C++. Can't wait. What a shame. Okay, catch up with him in the chat, you guys. All right. Skip PyTorch altogether. I know, right? Go straight to C++. That might be something that we choose to do here in a bit. Let's see. libtorch. Let's get it working in Rust first and see what that's like. And then libtorch C++ tutorial. Then we'll start looking at the C++ here. Using PyTorch C++ frontend. Hey for C++. Tensor. Ooh. Hey, that also looks pretty nice. Hey, that looks good. Okay. So a lot of colons though. As long as there's not too many abstractions. Yeah. Rust having guaranteed safety is nice. There we go. Neva. Hey, there we go. Getting ideas from Neva. Thank you. Okay, so where are we at here? I need to pip install. We got those. All right, so we're on the right version here. Looking good. Oh, wait, I need to tmux this up here. Pip install. Can we try that? Wait. Oh, whoa. Thank you for the hearts, you guys. Hey, look at that. All right, we got in progress now. Rust Power Checker makes it hard. It does. It does a little bit, doesn't it? All right. Let's try this. Upgrade a smidge and then try it again. Looks good to me. Hey, all green. Hey, we did it. All right. We've got everything in the right spot now. We do. We've got all in the right spot. So let's see if we can get this. Let's see if we can get this to work. Where is our... Here we go. Okay. So cd the my first torch. All right. Vi cargo. .toml. Looks good. Torch 24. All right. cd my first torch. tmux. There we go. Okay. Cargo build. Oh, it might work this time. There we go. Nitwa, you are inspiring me a little bit. To C++ should be pretty straightforward like we did in Python. Yeah, that might be the next thing we do. I think that might be right. We're going to try Rust first. We're going to try Rust. I think this is going to be fun. And then we'll get into C++, you guys. I think that would be a good plan. Sounds like a good plan to me. Okay, let's make it happen. Let's make it happen. This is so cool. All right, vi source main. Okay, let's see if we can get our hello world going. Okay, let's do this. Use torch. Use. Oh, this is so TCH. Tensor, right? It's gonna be a tensor. Oh, that's so clean. Look at how simple that is. Oh, I love it. Okay. Let tensor equal tensor from slice. Sure, why not? And then we're gonna say an address of a whole bunch of numbers. And then we're going to let t equal t times 2, maybe, right? Is that right? Print, probably print ln, exclamation point. Oh, I can just do t.print. All right. Let's see what that looks like. T.print. I'm not familiar with that. All right. Looks good. That right there. Cargo build. Cargo run. Oh no! It exploded. Library not loaded. All right. Let's see here. Let's see here. Why is my... There it goes. Okay. Cargo run. It builds. Let's say so. We build and run. Okay. I want. We're gonna get some help here. Back in Python. Oh, we're still doing Rust. We're still doing Rust. Use PubNub to instantly add items to your app. Check it out on link share. Oh, okay, yeah, let's do it. Back to Python. Amzad, we might. Right now, we're doing PyTorch in Rust. A little bit of extraction there. libtorch. We're doing libtorch. libtorch in Rust. So did I? What did I do that's wrong? Did I type it wrong, or did I do something else? All right. Copy. Go. What's wrong? You just helped a friend with their startup. Help them design the architecture for the... Hey, Stephen A. Quantified Quantum. Good to see you. Welcome on in. All right. Find your PyTorch library path. I did. Copy. Okay. It's going to run there for a second. Run your project with that path. Oh, do I really? Do I really? How about I just put that into my... all right. Well, why don't I just put that into my export? vi.zshrc. zhrc. There we go. See, I have it right here. Isn't that the same thing? So what did I print out? There, let's close that. So let's copy this. It's the same thing, right? No, it's different. Oh, I did it. No. Oh. No. No, that's wrong. Oh, I know. Oh, okay, I see. I know what I did wrong. Okay. I'm running the wrong virtual environment. Deactivate. Source. .forge bin activate. Okay. Now let's do it. Oh, it's still broken. This is one of the problems. What are you building? Manish, hey, good to see you. Welcome on in. Happy Sunday. We're trying to get Torch library to run in Rust. And we have some challenges. We have a little bit of challenges here. Target debug, where is this at? So it wants me to do this. Here we go. We're going to figure this out, you guys. We're going to figure this out. Let me get the songs going again. There we go. Okay. We're going to make this work. Don't worry. This is the plan. We've got no other objective today other than just getting this one little simple compilation working. Then once we do, we're going to sort of look through to make sure that we understand the code base, and we're going to start building with Rust and AI. That's the plan. You guys. Okay. Let's see. Python version. Yep, looks good to me. Okay. Pip install. Let's double check that we did this. Okay. So I forgot to do this part. All right. Let's also upgrade really quick. Reinstall. Looks good. Okay. Build. Run. Still a problem. Okay. Let's try this. Vi ZSHRC. Export. Whoa. Like that. Easy. Okay. Okay. Run. It's still not working. It seems complicated. I know, Sergio, it is. It's complicated. You got it. Why not do all in C++? A Ryzen CPU. Good to see ya. We might just do that. First, though, Neva inspired us, and so I want to follow through. and I want to get this running in Rust at least, at the very least. At the very least. Oh, I didn't know you could do that. Oh, this is neat. Oh, I didn't even think of that. Okay. That's a really good idea. Okay. Deactivate. All right. Vent bin activate. And then at the very bottom. There we go. That looks good to me. Okay. This looks good. Okay. And then also in the... Oh, we've got a toml option as well. We'll just do it in the virtual environment. Okay. Source. Okay, here we go. All right. Build. Run. There it is. We got it working. All right. Check it out. Boom. Easy. Oh, that's so nice. I wonder if we can also print this. Print ln. Hey, we did it, you guys. We did it. T right there. That's so awesome. If we can do this. All right. Run. Hey, look at that. Okay. Ooh, there we go. All right. Now we can build with some Rust. We can build with Rust and libtorch. That's great. I love that. I love that. Which operating system are we using? All right. So just type uname, and you can see here that we're running Darwin, which means Mac, basically. We're running Mac. You always believed in me. Hey, thank you, Kyle. Gotta go, Loons. All right. Sounds good. Also, your Windows installation, 10 gigabytes. That's a lot of gigabytes. That's a lot of gigabytes. Oh, look at this. It's so good. Oh, it's so good. Let T equal... What else can we do here? Are there some other fun things? So now that we've fixed that, and let's see here. We need to get rid of that. That's gone. I want to do... Yes, here we go. Let's do something a little bit more tricky. Oh, we could do our own gradient descent. No, that's fine. I don't want to do that. I've already done that. We don't need to do it more again. Ayo, Bonzupi. Now you got to clean up the slop. You left on your ZSH. Oh, wait. Oh, we did. We did. Don't worry. We did. Here, I'll show you. ~/.zshrc. Yeah. All right. So... Oh, you're right. You know what? We don't need this anymore. Hey, Bonzupi, thank you for the reminder. Oh, we already did it. Nope, apparently I didn't. Done. Oh, thank you. Bonzupi, thank you. I would have had that in there. I'd be like, why isn't it working? What happened? And it was because because I forgot to turn it off. Thank you, Bonzupi. Thank you so much. Can you look at your video? Yes, sorry. Let's do that. Thank you for the reminder. Kyle, I completely forgot. Here we go. What are we looking at? I can't hear it. We're going to... Wait. What'd that say? It's not... I can't hear anything. Okay, it says, we're going to figure this out. We're going to figure this out. Oh, wait. Oh, that's me talking in the background, isn't it? The closed captions heard it. What? That's no way. That's crazy. Kyle. So you've got... live real-time updating. So you in your phone, you grabbed your phone, you took a video, and you recorded that right there. And then it picked it up and it put it directly on your site instantly with PubNub. That's so cool. You streamed the background and added it with the app without refreshing the app. That's so cool. Right there, you guys, right there. That is awesome. See it again. Yep, boom. Added. Instant. You have one. I have one too. And there we go. Rocks. There we go. Very nice. Kyle, that's amazing. Kyle, that's fantastic. That is fantastic. All right. Let's do an XOR. Let's do an XOR really quick. Or maybe not really quick. All right. So we'll say let PubNub in action. LOL. Hey.
PubNub in action. LOL.
Kyle, thank you. Appreciate it. At Flip with Kyle. That's Flip Profit, you guys. Flip Profit. Flip Profit. Kyle, thank you. Party Popper. There we go. Boom. Kyle, my gratitudes. You've been so good to me today. Thank you so much. Thank you. Thank you. All right. So we're going to say let features, features equals torch.tensor from slice. We might as well, right? And we're going to say like this. Do we do ampersand? What if we do multi-dimensional tensor? Is there any tricks to that one? Like a 2D tensor? You have to double slice it? Hello, Mr. Blum. You read my recent comment? Hey, Erdem! What'd you say? I gotta scroll back up. I missed it. Mr. Blum, can you read my recent comment? I saw it again. Hey, let me see. Go to channel activity. Here's what I'm looking. Hey, Mr. Blum, can you share ghosty config file? There's nothing in there. There's nothing in there. I'll look at it though. Ghosty settings. Here you go. See, it's empty. It's empty. It's all commented out. I do have a few things down here though. Here. I've got some special key bindings, which you probably don't want. You don't want to deal with that. And I've got some font sizes. Right? And I've got some color palettes here. Groove box color palette. Would you want this on Discord? I'll share it to you on Discord. Just beware that these extra things at the bottom you might not want. You might care about this. You don't want that for sure. All right, I'll put it on Discord. Here we go. I'll put it here in Discord. I'll say... Here we go. I'm going to get rid of the thing that you definitely don't want. You don't want these guys here. All right, I think that's looking good. I'm going to get rid of all this commented stuff out at the top as well, so to keep it simple. Here you go. Boom. Okay. Does that look good? I think that looks good. Okay. Here we go. Ghosty config. That's the ghosty config. Ghosty settings config. Perfect. Okay. All right, we're going to do a quick little XOR, and we're going to see if we can make that work. Singleton pattern. Ooh, I love the singleton pattern. Nice, Kyle. I'm with you there. Competitive edge without hammering our back end. Yeah, keep things efficient and fast. Fast and efficient. What is the apply T? I'm not used to that. Okay, let's go back to our code real quick. We're going to say features is going to 1, 0. And then I'm going to go print ln features. Let's see, here we go. And then run. That's called wait, did I not save this? Oh, right there. There we go. Okay, looks good. Now, can we do multi-dimensional? We do multi-dimensional. Does it need to be an ampersand? Slice of slice? All right, how do we do a multi-dimensional? Ghosty is written in Zig. Did you know? Oh, it's in Zig? Well, they did a good job with it. They did a really good job with it. Bunzoopy, fantastic job. Good job, Ghosty developers. Aha. What do we do here to get a multi-dimensional tensor? The trait, element, target. Okay. Is there going to be instructions? Because I want my tensor to be multi-dimensional tensor. How do we do that? All right. Let's look this up really quick. Let's see here. Gemini. Let's see. TCH torch in Rust. How to multi-dim a slice tensor. Okay. It was mostly one dude. Just one dude who wrote the entire thing. Oh, you could reshape it. Well, that's annoying, but I can deal with it. Okay. I'm fine with that. Is there other approaches? Oh. Yeah, okay. I'm gonna do that. That's what I'd rather do. Because, here we go. Let data equal. This will be the ampersand. And then we're gonna have a bunch of options here. So it's gonna go 0, 0. Thank you. And then we're gonna actually keep it a little bit more clean here. And we'll do 0, 1. And then we'll do 1, 0. And then a 1, 1. Like that. Okay. See if that works now. All right, we good? Are we good? Yeah, looks like it's being good. Okay, here we go. Oh, wait, no, just kidding. It didn't like that. Again, really? I thought we were good, though. I thought we were good this time. Slice 2. Okay. Hey, there we go. Okay. So we need to use a very specific... We do it this way. Okay. So there's a specific per rank. We gotta do rank. It's gotta be in the function. I find tensor transformation hard in Torch. We need constantly debug tensor shape. Yeah, I have that problem in PyTorch even too. Like, what's the current shape of this? What's the current shape? And the fact that we have to do extra slicing. Okay. From slice 2. All right, so I like this. Okay. Okay, so this is our features and our labels. Let data inputs. Call it inputs. Let outputs or targets. Targets equals. We're gonna do a double again. How about we do this? 0. There we go. 1, 2, 3, 4. And the 2 in the middle are 1s. We say let labels. Targets. Okay. Now we got our training data. Easy. I like our training data. It looks good. What do you want to produce? We're going to do a quick little tutorial with PyTorch, libtorch in Rust, which is the XOR. So this is going to be the XOR model. Really quick, easy. Just an MLP. It's an MLP. Okay. And I want a linear. So we can do a sequence. I like that. That's pretty neat. We could do a sequence, you guys. So you can add an in torch.in. So we'll just do this straight up like this. Okay. I like this now. I like this. This is easy. This is easy here. All right. So we're going to have our... So how do we want to do this? So see, this is so much nicer. Like, look at this right here. It just makes me smile. This is great. Hey, $5, Kyle. Thank you so much. Hey, Pubnub. Kyle, thank you. Whoa. That's like, you're hitting records, Kyle, at Flip Profit, you guys. Flip Profit. Thank you. Go. Party Popper. Kyle. You're the GOAT. You're the GOAT, Kyle. Slices are memory heavy. Why don't you use indie arrays? Oh, Ahmed. Tell me about that. Type that in. Type that into chat. Type that into chat so I can make it better. Indie array. Show me how to make it better. Type it into, definitely type it into. Kyle, thank you again. My gratitudes to you. That's so nice. Kyle, appreciate it. Putnam are going to start a trend where all the youngsters say, and then I don't know, like 6, 7. Yeah, exactly. That's the new 6, 7. I know. That would be very surprising. That would be very surprising and impressive if you were to achieve that. It's called Indie Array. Search it up. I forgot the literal pronunciation. Okay. All right, we'll search it up. We'll do this. All right. All right. How to do Indie Array. Okay. First chat GPT and Rust. Ooh, Horizon, maybe. Maybe. Let's see. So is this it here? Like that? Define array. Features.reshape. Oh, Indie Array. This is a libtorch though, right? So it needs to work in Torch. Using TCH. So TCH tensor. Man, you're fast, Sergio. Hey, I know we made it. We're gonna make our way. It won't let me. There's no option to do Indie Array. Indie Array is another library, and we want to use tensors, obviously, because we're using the Torch library, right? So we have to use a slice, or we have to use. It's embedded right there. It's right there. It's fine. I think we're doing fine. I would like to make it better if I could, though it says not. As long as it implements shared traits, ask what traits are needed to have it. Let's see. All right, so what traits are needed? Let's see what that means. We're going to find out. Function, you don't actually need to bring any extra traits. So it says no traits. What does that mean to you? To me, that seems fine. Right? Doesn't that mean fine to you? Slice of fixed array, slice of vectors, a slice of a vector of vectors. And we're just doing a slice of fixed arrays is what we're doing. That seems plenty fast. We're moving fast, Sergio. You got it. I see what you mean now. I got it. I won't believe ChatGPT here. Oh, well, this is Gemini. Oh, dang, Rust. Hey, yes, we're doing some Rust. That's right. You got it. We got some Rust going on today. Please look at why trait it implements. Let's see. Which traits will you need down the road? No, I'm going to ask it here. Say, why trait it implements. Gemini is worse than ChatGPT, I believe, for more. It's been doing pretty good. What traits does it rely on from your inputs? Even though the method itself isn't a trait, it places trait bounds on the parameters you pass into it. The outermost structure must be a slice. So, as far as I can tell, everything looks good. I don't see any improvements here. I think this looks okay. Another Kyle in chat. I know, right? Kyle McDermott. Good to see you, Kyle. Got the other Kyle going here. Okay, so I want to... Can you show the signature of the code again? Right here? This is all it is. It's right here. I mean, it's from slice 2. The signature from slice 2. Looks fine. Reference. As ref. Type. You really expect for Google to be a lot better in the AI race? They are right now. They're getting so Anthropic is, and AI is, they are Anthropic and AI. Yeah, they're winning. They're winning. They're eating their lunch. They're eating their lunch, you guys. All right, so I'm happy with this. What I want to do next is we can do a sequential. We can create ourselves a net. Yeah, no, you're good as ref. All right, is in core. Nice. All right, Neva, good to hear. So in those traits, the main point, the control, the data, and transformation. All right, Ahmed. All of those are needed in your journey. All right, we'll make it up. We'll grab them when we need them. When we need them, we'll grab them. So I'm going to... All right. Let's implement this. Let's do this. Okay. fn net vs. What is vs? I don't know what this part is. I'm not familiar with this here. Path. Arrow. Model. Module, right? Module. Okay. And then we're going to... This is just a function. All right, that's a straight up function. All right. And it's going to return a module. Got it. Okay. So this is going to be nn tch nn seq dot add. And we're going to do an nn linear. There we go. tch linear. And then, okay, I guess there's vs divided by, and this is going to be the name of the layer. So this will be, I'll just call this L1. Okay. And then we're going to say inputs needs to be 2. Outputs needs to be 1. Oh, wait, hidden. Oh, so we're going to have a hidden layer here. We'll do 32. So I'm going to make this a little cleaner. Looks good here. And then we're going to add another. This will be L2, 32, and then an L3, 1. Right? Yes. Okay. Oh, we need a default. Okay. I missed that. Default. There we go. All right. They also have it for Gemini. I've seen them talk about it. It's a really neat algorithm. Ooh. I like neat algorithms. Funky time. And then we could add an activation and then an output. Okay, let's do this. XS. Add a function. Ooh. Can we do tanh? Oh, that's neat. Oh, this is neat. I like this. All right, so let me align these guys here so it looks a little bit better. Clean, keeping it clean. Okay. Then we're going to do an add fn. And we're going to, oh, I kind of like this. I kind of like this here. This is pretty neat. xs dot tanh. Let's do that. Okay. Yep, looks good. And then we've got... All right. Okay. Let's see if we can build this. Unclosed delimiter. Did I mess it up? Yes, I did. How about that? Okay. Oh, I didn't like that? Okay. I thought I was being fancy. Hey, time to get rusty. Hey, York, yes, we're doing rusty. You got it. Hey, mathematician, scientist, good to see you. Welcome on in. Happy Sunday. Okay, we're doing some rust here, you guys. We're going to do a quick little, although I don't know how quick it's going to be, a quick, simple little toy model, an AI model in Rust using the Torch library. Happy Sunday. Good to have you here. And if you're familiar with XOR, we're going to be doing XOR. It's my favorite to try something out with. Let's see. Use, I'm not going to use it anyhow. Torch. In module. This is weird. Oh, yeah, that should work. Torch in module. Did I do this wrong? Is that typed wrong? It's TCH in module. Did I type this? Oh, implement. Okay. There we go. Okay, how about now? Build. Are we good? Still in the air? Okay. No, it's in. It's in. Oh, here we go. Sometimes the compiler gives you weird stuff. All right, we're good now, maybe? Is that good? Yep, we're good now. Okay, good. You love constant energy towards learning new coding? Yeah, there we go. That's what we're doing. Let's go. Let's learn new coding, you guys. Okay. I am interested in... All right, so we've got a run, which is... I'm just going to say our main. We don't need to worry about that. Don't care about that. I'm going to get my net. What is VS? Oh, var store. So this is going to be like our compute. I'm not familiar with this. This is new to me. So let's check this out. All right. Let VS equal TCH NN. It's going to be called var store. I'm not familiar with var store. New device. Where's our device? Oh, it's going to be up here. Okay. So I'll say TCH NN device, right? Is it under neural network? No, it's just under Torch. Okay. You're a new student and love a low level to understand. This is someday I will reach there. You'll make it, mathematician, scientist. You will. You'll make it. Steven, actually, constant energy in galactic. Varstore is probably what you use for a module in PyTorch. Yeah, okay. I've somewhat get, because I know what a module in PyTorch allows you to encapsulate multiple, I suppose, layers and things like that. And this wants a var store to be here, which is, I'm not familiar with this. So there's a little bit of abstraction that I'm not familiar with. Just kidding. The constant energy, Gaelic. I'm not familiar with Gaelic. That's why I didn't know. All right, so device CPU. I want to do device. We'll start off with CPU and then we go to MPS. Hi, good to see you, Ankit. Welcome on in. Happy Sunday. You have 900 experience. Isn't that the top? That is so good. Dang, look at that, Kyle. That's impressive. All right, you guys. I want this to work here really quick. Where are we at? Build. All right, looking good. Apparently that works. All right. Looking good. So we've got our net here. What do we call this? How do we invoke that? Ampersand VS? Is that what we do? Dot root? Sure. Not sure why. Let's try to build that. Could not compile. All right. Why do you not like this? I got optimizer. Don't need to worry about that. Don't worry about cost entropy right now. I just want to do a feed forward on this. I think that's all I want to do. Hey, Matthias or Matt. Hey, Matt. Good to see you. Welcome on in. Happy Sunday. Good to have you here. Let me see. Yeah. All right. So that's a function run. All right. Where are we here? So that works. This worked, or this doesn't work. Is that a problem? Or did we... Are we working here? Run. Why is this not... There's no... binding? Does it want me to do that separate? Did I type that correct? vs.root? Okay. Binding equals vs.root. And then we do an ampersand binding. That's what the compiler's telling us to do. I don't know, we're gonna find out. Oh, what do you know? Oh wait. Usually when we do this, it doesn't work anyway. Oh, all right, it worked that time. I have no idea why. Something here is about the allocation scheme. Seems to be a thread local translation of the C++, so it won't be annoying with and mute. With mutable reference. Okay. So you're saying the and mute? Something like that? Let's try it. Let's try it. So yeah, I don't know why, because even the tutorial isn't telling us to do this. It's weird, but it seems to be compiling. I don't know if it's gonna work or not. Yeah, it seems to be working when I have it like this. Okay, so we've got our net. We've got our net now, and I can do a feed forward on it. We can do a feed forward on the net. So let's see if we get the feed forward. Where's our net at? Where's our net? I want to do a forward on the net, please. Say dot forward, and then the address of our training images. What's M? Load data. So I've got other kinds of... So I don't know... We're going to try it. We're going to try it. We're going to see. We'll see what the forward looks like. So let out equals net dot forward in features. Print ln exclamation out. Okay. Forward net, but what it is though, because it's a module. Did I return it properly? I did. It's all there. There's not even a semicolon at the end. Why varstore even a thing? Exactly. I don't even know why it's a thing. I have no idea. Trying to figure out varstore is. Yeah, exactly. Seems like we're passing using and forward for writing stuff, which weird, this shared mutability. It is odd. I'm confused by this as well. Let's see, where's my, so I see my forward here. Accuracy for logits. I just want the logits. I only want the logits. Net.forward. I just want the logits. That's it. Do we need to do an ampersand on the forward? Okay. All right. What is it? What's missing? No method named forward, but it is. We made it work right here. All right, let's see. All right, see, we brought it in and it's not working. The trait module is not implemented for. Okay. Let's try that. Okay. So basically the whole thing shows you a C++ API. You see with many C++ APIs translated like Rust, like capstone LLVM. Got it. Sounds. Logic, but at the end instead of a C. The semicolon at the end, Stephen. Where? What line? Oh, thank you. Hey, all right. At least we got something working there. We got a thread panic, which is not what you want to see. Oh, because it's a wrap. Okay. So, I mean, Here. What if we do out? This. Thank you for the semicolon. We're returning the results. Okay. And now it just crashes. Result on unwrap. Yeah, I assume we're unwrapping here. So, and it's panicking or something. What is? Let's do this. Okay, so that works, but when we run the forward, it fails. Like it just crashes. It straight up crashes. Like the compiler is supposed. The point with Rust compilers is supposed to not crash. I feel like that's always like one of the things that I feel like it should do. Like, oh wait, this is definitely not going to work. Called result unwrap on an error value. Did I though? Bunzupi, just unwrap or okay. Oh, you're not returning the results. I didn't even write the forward. There's a shape error somewhere. No, maybe. Is that what this is? I mean, I'm not maybe, because I've got my input would be 2, right? Hidden dimensions are 32. Output is 1. Right? So 2, 1. Using an unsafe C++ library, which is why it's not memory safe. Oh, Bonzupi! Oh, okay, yeah, that's a good point. That's why we're seeing the crashes, because it's using unsafe. C++ foreign function interface is not memory safe in Rust. Bonzupi, thank you for the clarification. This unwrap should have been an exception. The issue is the torchlib was lazy and did not log an error. Got it. Hey, Minefield Daily, good to see you. Good to have you here. All right. I'd really like to solve this before heading out today. And the problem is here, obviously, because when I build it without this line, it works perfectly fine. This is where it fails. Let's see if we want to... Let's just do this. Let's see if this makes it better. Cross enter P. Cross enter P, and then we're gonna say and labels. Like that. Okay. See if that... See, it crashes there too. Okay. Yeah, not memory safe. Yeah, exactly. This is an unwrap from Safe Rust. Just a good old Rust panic. Yep. Good old Rust panic. All right. So here's what we're going to do. We're going to get some quick help here. La 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 la. La la la. Here we go. Cargo run. Okay. See if we get some help. Something that is not linking right. Well, it seems maybe. Use float slices. Oh! I mean, that would have been nice if I got a really good error on that. Right? There we go. And then the outputs should be integers, maybe? No, we'll try this. I'm fine with logits of output of type float. That didn't do anything. Too kind. So we'll try this. We'll try this dot too kind to try it. So dot too kind. Torch. NN. Float. Torch kind float. Let's try that. Did that work? That worked. That did it. That did it, you guys. That did it right there. Okay. So it was a data type problem. That's what it was. That's what it was. Did you finish the Chat GPT project? I did, Hadar. We did. We got it to work. It reproduced itself. It worked. We did it. We made it work. We built our own. We got our multi-headed attention. We did multi-blocks. We did the transformer head, and we wrote the transporter block and self-attention all ourselves. All from scratch. Using PyTorch, of course. AI basically randomly guessing, ignoring it. I guess. I don't know. Turns out it was just a data type. And I'm not used to this. I'm not used to this. So, GG. Ah, J bro, good game. That's the face when you made it. You got a tears pass on my custom kernel module. Yeah. Right? It's like it finally works. Here, I want to see what the outputs are. I want to see the logits. Here we go. That's what I want to see. Forward pass success. Can I do an MPS? Can I do MPS? Will that work? See if that works. Yeah, oh, it doesn't like it. Okay. Well, that's a problem. Fine. Fine. We'll stick on CPU for now. The face. I know, right? The face. You're like, yeah, we did it. Success. All right, so let's, is that loss? We'll do loss equals out dot cross entropy. And labels. There we go. Let's print out the loss. Aw. No! No, really? Oh, come on, really? That's unfortunate. That is just unfortunate. Steven, can you open this as an issue in Torch? Because we can fix the error that gets logged to be nicer. Yeah, that would be right. It should log the error properly, but instead it just unwraps on a try into or something like that. That would be really nice, right? That would be really nice. It's a... Joy, how's it going there, Joy? Good to see ya. Happy Sunday. Okay. So... TCH, Rust, GitHub. Is there going to file an issue? New issue. We say... nicer error, please. All right. So, function F2. There we go. Rust. Okay. Okay. And then I'm going to delete this, yeah? Keep it clean. Okay. Because you asked, Never, because you asked. And then the output is... Where is this at here? Let me do this. Oh, you know what? They kind of do already, Neva, right here. Mat1 and Mat2 must have the same D type. It's already there. It's already there. I'm gonna... I'll open it anyway. Okay. Would be nice if the error was only, you know, a data type issue. So this is good because we learned something new. or easier to read. All right, there we go. All right, now, boom, done. I may make a PR. All right, that sounds good. All right, well, we submitted the issue. Just a matter of reading the error properly. Yeah, it is, yeah. Oh, it's not fair, though, because the error is ridiculous. The error is ridiculous. Did we... Oh, we didn't finish. Oh. Why is this... Why is... There we go. Oh, wait, it's gone now. This is weird. Oh, I see. Got it, okay. There. Good, good, good. Okay. So, let's get that back there, and we're good to go. Okay, so we're gonna wrap up, you guys. I got my logit output. I like Torch lib way better. It's much nicer. What's up, my brother? Hey, the Fort's good to see ya. We're wrapping up. We're wrapping up now. We started doing, so here's what we did today. We took out the burn library and we took it for a test. And we kept running into success. However, success at the peril of extreme abstraction. Watch this. Let's see here, /burn. Burn. And then we say source, module. A lot of abstraction. Like stuff like this. Like a ton of things like that. Burn. Source training. Like, as you can see here, there's just a lot of abstraction and a lot of boilerplate just to get a basic model to work. So Neva was very kind and said, hey, guess what? There's something that you want, Steven. You want this. Use the Torch library instead of Burn library. And my life got way better. So that's what we got to do. So we'll be back tomorrow. We're going to play more with the Torch Rust, the Torch PyTorch Rust library, basically. Tomorrow. That's what we're going to do tomorrow. More PyTorch and Rust tomorrow. That's the plan. All right, bye, guys. Had a good fun. It's C++ error. I think the trace from C++ library is causing it to be so bad. There is the trick. I'll let you ignore the C. Oh, there's a trick. That would be nice. There may be a trick. Okay. There may be a trick that we just don't know about. Maybe we'll figure that out tomorrow, you guys. All right. Thank you so much for joining. We'll be back tomorrow. More Rust and more AI tomorrow. Bro, do you watch WC? What is WC? I guess I don't watch it. I don't. Unless you're like Westworld or something. I don't know what WC is. All right, you guys. Thank you. User ID? Tell me about it tomorrow, because we'll be back tomorrow. Thank you so much. Bye, guys. Bye, Bonzupi. Bye, Neva. See you, user. World Cup. Oh, World Cup, of course. Sports. I probably will run into it. I'll probably run into it, because it's going for a month and a half, so I'll probably run into it. See you guys tomorrow. Bye, everybody. Have a good rest of your day. See you tomorrow.